Hi everybody, my name is Jimmy Carroll. I'm the Vice President of Operations at Tech B2B Marketing. I'm here at SPIE Photonics West 2024. I have the pleasure of being joined by Fel Legrand and John Lewis, my colleague. Fel works for Gentec-EO. For those who don't know about Gentec-EO, Fel, would you mind giving us a little bit of the background and let us know a bit about what you guys are excited about here at the show today?
Sure, thank you for having us. So first, Gentec-EO, we're a manufacturer of laser, beam, diagnostics, and performance devices. We allow our customer to measure laser beam power, beam energy, and beam profile, as well as terahertz sources power measurement. So it's diagnostics tools integrated in machines, in production facility, in labs to measure the laser beam performances, basically.
So for people out there who don't know why you would measure laser power, let's say, and count me among them, because it's a bit new to me on this side. What's the reason for that?
So one great example that I like to present, eye surgery, for example. You want to be sure the laser pulse energies are calibrated to the right amount of energy to just process the cataract or other things you need to do properly. Not too less, not too much of laser power energy. So you need to calibrate the device. Same for a production facility running welding or cutting application or additive manufacturing. You want to be sure that your build, your layer by layer build using fiber laser, 1064 nanometer and so on, going to the layers of copper, aluminum and so on, is targeting the right melting temperature. So they need to measure. And above that, even better, they need to measure live during process using an optical pickoff sometimes to be sure, okay, I have my 2.5 kilowatt of laser power going to this sample and I can adjust this. Oh, this is dropping a little bit. I need to adjust it to make it a bit bigger and so on for the process requirements.
So, not to simplify this, right, but would you say that folks out there who may have received LASIK surgery, they may have Gentec-EO to thank for their eyes not melting?
Definitely.
Yeah.
Yeah.
Okay, fair enough.
Yeah, and how it works is either during the process and not necessarily during the eye surgery, but they measure the laser beam pulse energies before and after. They have some maintenance routine and check. They do that every day, every week, every month, and they use a suite of detectors, and amongst them there are power meters from it.
Yeah. And I'd like you to elaborate more on the terahertz source measurement and analysis. What is a terahertz source?
So a terahertz source, this is this place in an electromagnetic spectrum between radio waves and basically infrared light. So this is more and more thought after for application for non-ionizing beams, basically for airport security, for example, like trying to get a way to see about any hidden objects and things. So using this non-ionizing radiation to probe objects to see if there are any defects inside. There's a lot of manufacturing defects in production line, shooting terahertz radiation at the plastic parts and so on to see about any defects inside and so on.
Oh,
so, and we don't make those sources as usual. We make tools to measure the power in watts, the pulse energies in joules for those sources. Yeah.
Can you talk a little bit about why it's important for manufacturers to use these measurement and analysis tools?
Sure. Many things could happen. Let's say you have degradation over time in optical components, fiber optics delivery and lenses and collimators and so on. Everything that would degrade over time. So after a couple of weeks, months, years and so on, you could see your beam shape change, your focal spot move along the propagation axis, and just the power level decreasing over time. So if you integrate proper measurement devices, communicating with your interfacing and your control tools at the facility, you will see the drop in power. Okay, oh, my laser is not performing as expected today, so I need to maybe replace something. You could run some analysis with all the data you gather. Machine learning has a bright future in that. You could run some lot of testing and measurement. As well for alignment, we see a lot of customers using remotely controlled tools like beam profilers to see about the alignment of beams inside a collimator, inside a set of lenses and so on, and they adjust where the beam is going live using those tools.
One question I want to ask about, and correct me if I'm wrong, like I said, full honesty and disclosure here is like, my background is more on like the industrial automation side.
Okay.
So some of these questions may seem silly, but I'm venturing a guess that the use of lasers is important in an area like EV battery manufacturing. And that's a space that is kind of an upcoming and maybe not emerging, but increasingly important application for the machine vision folks. Is it also for the laser side? And if so, where does your product come into play?
Yeah, great question. Forced battery welding is strong. Couple welding, for example, using blue light or near IR 1064 nanometer light. That's a strong application case and use case. And our customers, they ask themselves usually two questions. How am I going to get the most accurate measurement of my laser power? Again, before commissioning a new laser, I need to set the right parameters. Okay, to weld copper at this speed, I need this kind of power level, so I want to be sure what the laser that I'm buying is providing me these 600 watts that I need. So control checks and quality controls. So how do they make the proper calibrated measurement? And I like to remind that the accuracy as we operate, Partners for Accuracy is our motto, is a combination of two things. First of all, the measurement repeatability, how close two consecutive measurements are from one another, and the calibration uncertainty, how close the reading in watts or joules are to the true definition of the watt joule. Comes the National Institute of Standards and Technology, the NIST standards that we use to calibrate our devices. So first, they want to make a proper, accurate measurement, and then they want the detectors to work for them. Customers, they connect it over serial commands, serial communication, Ethernet, wireless, and everything using .NET environment, Ethernet, as a Python scripts right now, or LabVIEW or anything, and they want to gather as much data possible and to predict what's going to happen. Okay, I know, so, okay, when I see this trend in my laser power going up or down for whatever reason, usually it tells me this is because I need to change this component, so I can act as a preventive maintenance fashion.
Are you seeing any notable trends in terms of customer requests in certain industries?
Sure. Faster, higher power, smaller beams.
Cheaper.
Yeah. It's part of the release of the, for example, the 50 kilowatt gold cone detector that we released, we're releasing at Photonics West this year. It's to increase the capacity as far as total average power. We're talking, so burning stations for fiber lasers, so measuring for long-term duration quality control on lasers, or some directed energy applications. It's a huge amount of power, and they want to use small beams. So we come up with this gold cone design. That's the trend. Smaller beams, high power, faster response. We came up with an integrating sphere sensor, so up to 1 kilowatt for now, water-cooled, with a photodiode inside of it, so benefiting from the rise time of photodiodes. We're talking 200 milliseconds, so very fast rise times up to 1 kilowatt of the power. So fast measurements, accurate to NIST standards, high gamma thresholds, same thing, so high power density, high energy density, and so on. And the versatility as far as controls, again, serial commands or anything that could just interface with your control suite and monitoring solutions.
You talked about the 50 kilowatt high power laser beams. Can you talk a little bit about some of the applications that those beams are used in?
Yeah, faster laser cutting, for example. The more power, the faster you cut. For metal sheet cutting. Welding, directed energy is one example. And if you go to the pulse side of it, one fascinating application those days is nuclear fusion and inertial confinement developments. The NIF, for example, National Ignition Facility, are using our probes to block safely and measure the energy of the single pulses they send to those targets to trigger nuclear fusion. So the trend is to go higher energy, shorter pulse width, for example, so higher peak power, so detectors more robust to block those beams safely, not explode, and make a proper measurement of it in joules.
And how about applications for the up to 1 kilowatt laser?
Typically additive manufacturing is in its range.
That makes sense.
So layer by layer, and we see providers of additive manufacturing machine either setting the proper parameters for a given build. Okay, I need this power level, 500 watts, this scanning speed, and this beam size, and I need my M squared to be, which is the beam quality factor or power meter. I need the M squared to be in this range and so on. So they could just define the proper recipe for a given build, and we're talking making rocket nozzles or medical parts with the crazy shapes inside and with vacuum parts and so on, which is not able to, we're not able to make that with conventional manufacturing. You need the layer by layer approach. Either that or they go live using optical pickoffs, so just a fraction of the laser power going to a photodiode or a sensor to measure the beam power live and adjust it depending on how the build is going, heat loads and repetition of heat fluxes and so on. Okay, I need less heat here because that will be too much for the powder to melt and so on, and you can adjust the build this way. So Additive manufacturing is a great example for 1 kilowatt range. Yeah.
Fel, what else are you guys excited about? Both, not just for your company, but in the let's say the general photonics space. What are you guys most excited about?
Honestly, nuclear fusion is really exciting. If we're talking carbon-free energy triggered by lasers, of course, that will make our day. Telecommunication as well, free space telecommunication. Talking satellites exchanging data using laser beams, which is encoded, or I'm not sure if it's the phase or the amplitude or the repetition rate that's modulated, but the low Earth orbit satellites are using lasers to communicate. So we're seeing this trend in measuring more and more lasers here. And medical devices are going strong. Eye surgery is a great example, something someone could really rely on.
As soon as you said eye surgery, what's the importance of measuring laser power? And you said eye surgery. I said,
And you said,
okay, that's it.
there you go.
I understand.
Yeah, I have one more question. I noticed you also have recently introduced a 195 millimeter detector for wide laser beams. And I'm wondering, can you talk a little bit about what led to that development and what kinds of applications these wide laser beams are used in?
Definitely. So we're talking a large pyroelectric sensor measuring pulse energies in joules. So not to measure average power in watt, but for pulse lasers. It's typically driven by research labs and high peak power facilities. Nuclear fusion is an example.
Okay.
So because the trend here, if we're talking this field, which is very exciting, and by the way, we're starting to see maybe some crossovers between industrial laser manufacturers and the capacity they have to enclose the system and make it industry ready, and those more research labs for nuclear fusion trying to speed up the repetition rates, because if they go 1 shot per day, that's not enough. If you want to build a power plant around that, you need at least 10 hertz. So high peak power, high energy pulses with a good repetition rate. So that's why we come up with this design. It takes up to 200 hertz, 700 joules per shot. So it's to take a huge amount of peak power and to still have a reliable way to measure the pulse energies. So a robust, calibrated way to measure the peak power or the energy per pulse, and provide the tools to be sure they develop the right lasers and the right system for those applications here. So nuclear fusion development is the right example for this detector.
So if people want to learn more, it's Gentec-EO.com, is that right? Gentec.
Correct.
Or the LinkedIn page.
Yeah. And with the resources online, the blog articles, and the product finder. Because sometimes we spend a lot of time talking about specs and so on. Customers that like to spend their time answering the laser spec themselves in our product finder, get a pre-selection of products, and then having a discussion with them.
Well, John, if you don't have any more questions, I want to thank you for your time, Phil. I really appreciate it. I know
Thank you guys.
This must be a very busy show for you, so it's valuable time that you shared with us, and we appreciate it.
Appreciate it likewise. Thank you.
If anybody has any questions for Fel or Gentec-EO, they can reach out to us. We'll be happy to pass them along. If you don't, go to the website. You can reach us at manufacturing-matters.com. And thanks so much for either watching or listening.